Hello friends, myself Praveen Yadav, Assistant Professor in Mechanical Engineering Department, Sharad Institute of Technology, College of Engineering, Yadrao. Today we are going to discuss about Introduction to Noise. In this lecture, we are going to cover the fundamentals of sound, introduction, parameters involved for the measurement of sound, subjective response to the sound, frequency dependent human response to the sound, and sound pressure dependent human response. So the objective of this lecture is to learn about fundamental concept of sound and to understand human response to the sound. The expected outcome will be the student will be able to understand fundamental concepts of sound. You will be able to differentiate between noise and sound, and you will be able to analyze the effect of sound considering sound frequency and sound intensity. So, what is meant by sound? Sound may be described as disturbance that propagates through a physical medium, and that physical medium must be the elastic medium. Sound does not propagate without medium. Sound always propagates through the elastic medium as shown in figure. The figure shows the propagation of sound in air. So the sound propagates in a forward direction, longitudinal direction, with the help of compression and rarefaction alternatively as shown in a figure. Sound is always created by vibrating object, and sound propagates as a longitudinal wave in which the particles of the medium oscillates parallel to the direction of propagation. Waves that are propagated through the elastic medium is called as mechanical waves. So basically sound is a similar like to the vibration generated due to the vibratory body only, and it is radiated to the surrounding, which is covered either with the help of any kind of elastic medium, which should be the physically present at there. Remember, sound never propagates through the vacuum. For sound propagation purpose, there should be always elastic medium. Sound is pressure oscillation in the air which radiates away from the source. The elastic properties available with the medium enables transmission of disturbance from one position to the another. When these waves hits on an eardrum, it converts into vibration and resonance. Resultant sensation or physiological sensation response given by the human auditory system is called as a sound. The sound pressure is the incremental variation about the ambient atmospheric pressure. Now there are n number of parameters are involved with respect to the sound. The first most important parameter is the amplitude. It is similar like to your general vibration problem. The maximum peak given from the mean position is called as an amplitude. The second one is the frequency. The number of sound waves travels per second is called as a frequency. In other words, number of cycles of disturbance per second passes through the positive and negative peaks is called as a frequency. Generally, human ear responds to the range of frequency from approximately 20 Hz to 16,000 Hz. Now the next term is time period. Time required to complete one cycle is called as a time period. Time period is generally a reciprocal of frequency and it is measured in terms of second. Now the important parameter is wavelength. The distance between two like points on two successive waves, that is distance between two successive peaks or slags or at any two successive points is called as a wavelength. Suppose wave travels with the uniform velocity v through the distance of one wavelength, in a time period t, then wavelength lambda can be given as v by f, or it is equals to v into t, and its unit should be a meter. Now the next term is the velocity of sound. Velocity of sound is nothing but velocity of wave propagation. It is dependent on medium through which sound propagates. The speed of sound in air is given by mu v is equals to under the square root gamma p naught divided by rho, where gamma is called as ratio of specific heat at constant pressure to the specific heat at constant volume. P naught is the ambient or equilibrium pressure, rho is the ambient or equilibrium density. Generally, gamma is taken as 1.4 for the air, and therefore velocity of sound in air is 344 meter per second. Since air is the only less denser material or medium for the propagation of sound, velocity of sound in air is the lowest and is equals to 344 meter per second. In a water, velocity of sound is 1372 meter per second, whereas for steel it gives the maximum value of 5182 meter per second. So from this we can say that for a solid material with good elasticity, the propagation of sound will takes place with the higher velocities. Now we come to the main point, that is when the sound should be called as a noise, because every time every sound we are not feeling as a noise. Many a times the musical instruments creates a sound which we feel so very pleasant. We would like to listen that sound. Many a times some equipments create some noise, some animals create some noise, some sound that we wanted to listen. Then which sound is called as a noise and which not? Again, it is depend on it is a subjective response, because as a person, if I like any particular sound, then it is a pleasant experience for me. But for the same time, for someone others, it may be the hectic. It may create some mental pressure over that particular person, and due to that, it may be called as a noise for that person. So that's why before going to the differentiate between sound and noise, we have to discuss about the sound as a subjective response rather than the physical evidences, because measurement of sound by the help of some physical evidences is easier with the help of some instruments like microphone, then frequency analyzer, oscilloscope, sound level meter, sound pressure level meter, etc. We will be able to the physical entities, but we cannot be calibrate these entities into the sound, because again the important thing is that sound is something which is sensed by the human body, or some psychological effect developed on the human body. There is no any standard for the measurement of or for the calibration of sound according to the human perspective, and therefore it is somewhat a subjective response. Why it is called as a subjective why it is essential to think about it, because it is everyone's individual perception about the noise source characteristics and its subjective phenomenon. The sound wave is generally characterized by pitch, loudness and tone quality. Loudness is nothing but sensation of amplitude of pressure and intensity. Though loudness depends on the sound intensity, its relation is algorithmic. In general, loudness increases with increase in intensity, and it is also dependent on somewhat on the sound frequency. So if you want to increase the sound, then in that case we have to increase the sound intensity, and for that purpose we are using different kind of equipments just like an amplifier. Now pitch is a physical response to the frequency. Pitch is pitch is primarily function of sound frequency, but also slightly depends on intensity and waveforms also. In general, pitch of sound wave increases with increase in frequency and decreases with decrease in frequency. The spectral distribution of acoustic energy is known to produce a subjective response of quality of sound. A sound tone quality changes as the complexity of waveform increases. Generally, monotone sound is called as a pure tone. If number of sound waves are mixed together, and then if any resultant amplitude comes outside, then it is not a pure tone sound, and it creates the complexity of the waveform, and which affects the quality of sound. Musical instruments which gives a very smooth sound, these are generally having a good near about to monotone sound waveforms. The sound of single frequency is called as a pure tone. Pressure wave generated by the movement of diaphragm is in the form of a sine wave, and this simple sound is called a pure tone sound. A frequency of simple pure tone sound wave is called pitch of the tone. It is also known as the pitch of the tone. So in general we can say that pitch, loudness and sound quality are some sort a subjective phenomenon on which the sound is dependent for the human perspective. Now these subjective responses we are going to connect with the some physical parameters which are measured with respect to sound, known as frequency and sound pressure. So firstly, frequency dependent human response to the sound. From the research in the laboratory as well as in the survey, it is observed that sound at a frequency above 20 kHz is inaudible to human being. So sound above 20 kHz is called as an ultrasonic sound. So human generally not able to listen ultrasonic sound. Even sound between 15 kHz to 20 kHz is also audible to those peoples having very acute hearing capacity. Otherwise, for older peoples, sound above 15 kHz is unaudible. This kind of sound is generated with the help of jet engines, high-speed dental drills, ultrasonic cleaners, etc. Even ultrasonic sound waves are used in a sonar system, as well as ultrasonic sound waves are also used for non-destructive testing in material science. Sound at frequency below 15 Hz cannot be heard, but it can be felt only if they are sufficiently strong. Such sounds are called as infrasonic sounds. Infrasonic sounds can generate naturally as well as some artificially. The examples are wind, earthquake, sea waves, air conditioner, motor vehicle, etc. Now, frequency dependent human response to the sound. Human sensitivity is quite good in a frequency range of 1000 to 4000 only. For normal hearing capacity peoples, sensitivity is maximum precise at a frequency range of 3000 Hz. That's why in a field of industrial noise control, major focus is provided on the frequency range of 63 Hz to 16000 Hz, because sensitivity of human ear is greatly reduced between the frequency below 63 Hz and above 16000 Hz. So whenever we are looking for the problem in an industry in terms of controlling noise, maximum focus is provided for the frequency range between 63 Hz to 16 kHz. Above and below the limit, there is no need to take much more efforts. Threshold of hearing. The lowest sound intensity that can be detected at any particular frequency is known as the threshold of hearing or threshold of audibility at that particular frequency. Again, it is the subjective phenomenon. It depends on the person to person, its particular capacity, its age. Every factor is dependent for the threshold of hearing. As age goes on increases, there would be the progressive loss in sensitivity at high frequency. Human voice is spread over 80 Hz to 8000 Hz. So, loss in hearing capacity of an individual in a frequency range between 15 Hz to 80 Hz and between 8000 Hz to 16000 Hz cannot be detected during human conversation, because we are generating noise with the help of sound. We are generating sound between the frequency range of 80 Hz to 8000 Hz. Below 80 and above 8000 we are not generating the sound, and that's why peoples were unable to understand during the conversation about the hearing problems for that frequency ranges. So this is the effect of frequency on the human response. Now we'll discuss about the sound pressure dependent human response. Sound pressure or acoustic pressure is the local pressure deviation from the ambient atmospheric pressure caused by a sound wave. In air, sound pressure can be measured using microphone, and in water with the help of hydrophone. The SI unit for sound pressure P is the Pascal. Audibility again depends on the sound pressure. If for a particular instance sound pressure is very less, then for any frequency range sound is not audible to the human body. Minimum audible sound pressure for an adult with normal hearing capacity in the region of maximum sensitivity is 2 into 10 to power minus 5 pascals. The loudness of sound increases if at a given frequency sound pressure is increased. When sound pressure is more than equals to 20 Newton per meter square, the sound is so great that it cannot fail. This is called threshold of feeling. There is sensation of pain when pressure rises up to the 200 Newton per meter square. Sound corresponding to the threshold of hearing at 10,000 1000 Hz frequency is called zero level sound pressure, and the sound pressure at the 1000 Hz pressure frequency is 2 into 10 to the power minus 5. That's why it is called as a zero level sound pressure. In a nutshell, we can say that sound pressure should be always more than 2 into 10 to the power minus 5. As sound pressure goes on increases, loudness will be goes on increases. Here we end this lecture, and now what we have learned here, that sound, human response to the sound is dependent on the frequency as well as it is dependent on the sound pressure. If the frequency is between the audible range, if the sound pressure is between the audible range, then sound is audible to the human being. Otherwise the sound is not audible to the human being. Again, in an audible frequency range, audible sound pressure range, sometimes sound creates the effect as a noise, because unwanted sound is called as a noise. So how to bifurcate that with the help of decibel scale, that we are going to discuss in a next lecture. Thank you.